These are the lesson activities for Math 117 for section 10.4. So we're ready to figure out how much money Caitlin will have at retirement. So some of this information was presented in the demo and it is repeated here. So on her 22nd birthday, Caitlin deposited $1,000 into an IRA. Like Ian, she made a total of 10 equal annual deposits and then stopped adding money to the account. Assume that the IRA earns 7% interest per year, compounded annually. How much money will Caitlin have in her account the moment after she makes her last deposit? So I copied the formula from the previous page that gives future value based on monthly payments. So I am just going to fill in values for M, R, and N and calculate my future value. Okay, so my monthly, M is the amount of my regular deposit. It's yearly in this case, $1,000. Okay, and then I have 1 plus my interest rate is 0.07 divided by the number of compoundings per year, which they told us was annual, so 1 raised to the 1 times 10 for 10 annual deposits. And then minus 1 divided by R over N again, 0.07 over 1. Okay, so now I just need to carefully use my calculator, follow the order of operations. I'm going to start with my 0.07 over 1, that's just 0.07, and then I'm doing what's in parentheses first, so 1 plus 0.07 is 1.07. I'm going to raise that to the 10th. And I get a number, it's about 1.967. I'm not going to write it down because I don't want to round anything till the end, but it's in my calculator. This number here is about 1.967. I'm going to subtract 1 from it, and then I'm going to divide by 0.07, and finally multiply by 1,000. And I get $13,816. And 44 cents. Now, suppose that Caitlin opens a brand new account. It still earns 7% interest per year compounded annually, but I'm not going to make regular deposits. I'm just going to deposit this one amount, the amount from my regular deposits over 10 years. I'm going to move it to a new account that just makes 7% interest annually. So how much money will be in this account when Caitlin retires on her 64th birthday, assuming she makes no other deposits? So for this formula, I'm going to use my compound interest, my formula for compound interest. So it's present value times 1 plus R over N to the NT. This is just one deposit that compounds yearly. So my initial principal or present value is going to be $13,816.44 times 1 plus 0.07 interest rate over 1 compounding per year, and then time. Let's see, how many years have passed since I deposited this amount of money. So I made the first deposit into this account in part A on my 22nd birthday, and I made 10 total deposits. So on my 22nd, I'm just going to count this on my fingers because it can get confusing. So I made 10 deposits. So the first one was on my 22nd birthday. So 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. So on my 31st birthday, I made the 10th deposit. Count it on your fingers. Start on 22. Make 10 deposits. You'll see you make the 10th deposit on the 31st birthday. Okay, so how long I started this investment on my 31st birthday, and I'm going to retire on my 64th birthday. So how many years in between from 31 to 64? That's 33 years. So I'm going to put 33 here, and then I'm just going to carefully follow the order of operations and type this all into my calculator. So 0.07 over 1, that's 0.07. Add the 1, so I have 1.07 raised to the 33. And then multiply that times 13,816.44. And you get 128,842 dollars and, well, I guess we would round that to $43 because it's 0.997. To summarize, how much did Ian invest in total? So Ian made deposits of $2,000 10 times. So he put $2,000 in a year for 10 years, and so his total investment was $20,000. If you go back and check the demo, how much did Ian have at retirement? We calculated that he has $114,415.75 at retirement. Okay. And then how much did Caitlin invest in total? I invested $1,000 a year for 10 years. That's a $10,000 investment. Okay, $10,000 total. Only half of what Ian invested. $10,000 versus $20,000. Okay. And at retirement, we figured out I have $128,843. Okay. So the results above seem to illustrate a contradiction. Ian invested more money, but ended up with less. Caitlin invested only half of what Ian invested, but ended up having more money at retirement. So why do I end up with more money even though I invested less? Because I started earlier. Okay, so compound interest is powerful when given time to grow. Okay, so invest early. Okay, so there's a common saying like, when is the best time to start investing? And the answer is yesterday. But what is the second best time to start? And the answer is today. Suppose you invest $40 per month into an IRA that pays 10% annual interest, compounded monthly. Round your interest answers to the nearest cent. How much money will you have in your account in 10 years? So I grabbed the formula for money invested at regular intervals, and I'm just going to plug in all the things that were given into this formula. So my future value is going to be my regular deposit amount, which is $40, times 1 plus my interest rate is 0.1 over the number of compoundings per year. They said it was monthly, so that's 12. And then I'm going to raise that to the 12 times t, and t in this case is 10 years. Then I have a minus 1, and then I have to divide all that by 0.1 over 12. Okay, now I just have my calculator do all of this calculating for me. I just have to be careful to follow the order of operations. So when I'm looking at this whole thing, I want to work inside the innermost parentheses first. So I'm going to do this first. I should also mention there's some sneaky little parentheses around that 0.1 over 12. Okay, so work on the innermost parentheses first. So you do the division first, then the addition within the parentheses. Then our next step in the order of operations would be the exponent. So we'll raise to the 1/20th, subtract 1, then divide by the denominator, and then multiply by 40. Okay, so we'll do it all in this calculator. So I'm going to start with the 0.1 over 12. Hit enter. Okay. And then I want to add 1 to that, add 1 to the previous answer. So I'm going to use this button, ANS, for previous answer, and add 1 to it. So previous answer, and it just will type it out, and then you type +1, hit enter. And then I want to raise that answer, that 1.0083333333, I want to raise that to the 120, 12 times 10. So I'm going to use the A to the B button to raise the previous answer to the 120th. By the way, this calculator is a scientific calculator from Desmos. It's free. Anybody can use it. Just go to your browser and type this in. Okay, so take my previous answer, raise it to the 120. So previous answer, A to the B, 1, 2, 0, hit enter. And then I have 2.707. I'm going to subtract 1 previous answer minus 1, hit enter. And then I want to divide that, 1.707, I want to divide that by 0.1 over 12. So hit previous answer, divided by, and then I'm going to use some parentheses, 0.1 over 12, and hit enter. I get 204.844. Finally, I can multiply all of that by 40. Oops. Previous answer times 40, and I get 8193.79. 799 is 0.80. Next, I'm working on the same problem. All the parameters are the same, except I'm going to change the number of years from 10 to 20. So my future value is going to be 40 times 1, 1 plus 0.1 over 12 to the 12 times 20 minus 1, divided by 0.1 over 12. And we'll have the calculator do this again. Okay, so start with 0.1 over 12. I want to take that answer and add 1. Raise that to the 12 times 20. I can do that in my head. It's 240. So previous answer, a to the b, 240. Then I take that answer and subtract 1. Take that answer and divide by 0.1 over 12, and then multiply by 40. Oops. And I get $30,374. And 75 cents. Okay, I'm just going to repeat this calculation again, but with a 30 instead of a 20. So F is 40 times 1 plus 0.1 over 12 raised to the 12 times 30 minus 1 all over 0.1 over 12, and we'll have the calculator do it. Okay, so we start with 0.1 divided by 12 again. Enter. Take that answer and add 1. Take that answer and raise it to the 12 times 30, which is 360. Take that answer and subtract 1. Take that answer and divide by 0.1 over 12. Take that answer and multiply by 40. And this time we have $90,000. 419 and 52 cents. And we'll repeat one more time using 40 for t instead of 10 or 20 or 30. So that is going to look like F equals 40 times 1 plus 0.1 over 12 raised to the 12 times 40 minus 1 all over 0.1 over 12. And I am going to do it in a calculator, but I'm just going to do it off to the side here. I'm sorry that you can't see it. 0.1 over 12 plus 1 raised to the 480 minus 1 divided by 0.1 over 12 times 40. And we have 252,000 approximately. $252,963.18. Okay, question 4 is a two-parter. So we're saving up for a house. You can save $450 a month, and you're going to invest it in an account that pays 8% annual interest compounded monthly. you'll use your investment as a 20% down payment on a house. Okay, so let's just see how much money we're going to save. Okay, so our savings, we use the formula for future value of savings. $450 is our regular investment amount. It happens every month. And then we're going to multiply by 1 plus, my interest rate is 0.08. It's compounded monthly, so I'm going to put in a 12 here and raise that to the 12 times 5 because I'm going to save for 5 years. And then I'm going to divide by, I have -1 up there, I forgot. And then divide by 0.08 over 12. And then let's see what this comes out to on a calculator. This adds up to $33,064.59. Okay, so that is the amount we've saved. Okay, how much house will that buy us? Okay, if that's going to be our 20% down payment, how much house can we afford? And I'm kind of out of room, so I think here's what I can do. I can move this whole thing up a little bit. Okay, so I am going to take 20% of my house value, let's call it H, because I don't know how much the house costs. 20% of H can be $33,064.59. Okay, I want to know what H has 20% of it is $33,000. So I'm going to divide both sides by 0.2. Those cancel, and we get H equals 33,064.59 divided by 0.2, and that's $165,322.95. This is the house that we can afford to buy if we want the money we've saved to represent a 20% down payment. Question 5, suppose that we save money for 5 years as in the previous question, but that we wait another 2 years before we buy a house. Assume that in those 2 years we stop making monthly deposits, but we do allow the money we've already saved to grow at 8% annual interest compounded monthly. Then what is the most expensive house we'll be able to afford after 2 years? So let's see, our savings after an additional 2 years, I'm going to use the compound interest formula. And I want to know my future value. My present value is the money I've saved, $33,064.59. I'm making 8% interest compounded monthly for 2 years. So have my calculator do this. 0.08 divided by 12 plus 1 raised to the 24 times $33,064.59. And now I have $38,781.06. So there's my savings. How much house can I afford? Well, 20% of what would be $38,781.06. Divide both sides by 0.2. So the amount of house I can buy is $193,905.29. Sandy has won the lottery. She has 2 options for how she can receive her winnings. She could take one lump sum of $500,000 today, or she could get one check for $3,000 every month for the next 20 years. Assuming Sandy could invest her money in an account that pays 5% annual interest compounded monthly, which option should she choose? Well, we're going to calculate the future value of both options. So in the lump sum, she's just going to invest $500,000. We're not ever adding to it. So future value is just the compound interest formula. And future value is going to be present value, which is 500,000. My interest rate is 5%, compounded monthly. And she's getting the checks for 20 years. So let's see what this amount of money will be worth in 20 years. Okay, when we use a calculator for this, we get 1,356,320.14. And then monthly payments, we have to use the formula for investments made at regular intervals. So the future value will be your monthly amount times 1 plus r over n to the n t minus 1 divided by r over n. Okay, so I fill in my monthly amount is 3,000. 1 plus my interest rate is 0.05 over 12 to the 12 times 20 years minus 1 divided by 0.05 over 12. Have my calculator do this, and I get $1,233,101.01. Okay, so which option is better? The lump sum payment comes out to a greater value, assuming that you can invest every penny you get in both options. You would invest and not touch for 20 years.